Hello everyone, in this video we are going to solve the problem number 1.24 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A radius vector of a point A relative to the origin varies with the time as r is equal to at I cap minus bt square j cap, where a and b are positive constants and I and j are the unit vectors of the x and y axis. So let us consider that this is x axis and this is y axis, and we are having the radius vector. Let us say this is the radius vector whose tail is at the point A with respect to the origin, means that its tail is at 0, 0, and this particular radius vector is represented as r vector is equal to at I cap minus bt square j cap. If this is the origin, then point A can be written as the coordinate at comma minus bt square. Okay, and in the problem first it is asked to find out the equation of the point's trajectory y as a function of x and also to plot this function. So in the domain of x and y, any point we can represent it as x comma y. So we can equate x is equal to at and y is equal to minus bt square. Okay, and here we have to eliminate t because we have to write y as a function of x. So here we are having t square, so let us square this particular expression. We can get x square is equal to a square t square. If we substitute t square here, that is equal to x square by a square. Let us substitute in this particular expression. We will get y is equal to minus b times x square by a square is equal to minus b divided by a square times x square. This is the y as a function of x. Okay, if we carefully look at this particular expression, we can see that this is the form of x square is equal to minus 4ay, because b upon a square, that is the positive constant, because a and b is positive, and here we have negative, that's why it is of the form of x square minus 4ay. And we know that if we are having this particular expression, this is nothing but the downward parabola which is passing from the origin. So if we draw the downward parabola, then this will look something like this, and this particular axis is the x axis and this is y axis. So this is the graph through which we can represent y is equal to minus bya square into x square. Now let us come to the second problem. It is asking to find the time dependence of the velocity v and acceleration w vectors as well as of the moduli of these quantities. So let us say in the b part we are having the radius vector is equal to at I cap minus bt square j cap. If we write the velocity vector, that we can write it from by differentiating the radius vector or the position vector with respect to time. So we will get d by dt of at I cap minus bt square j cap. So if we differentiate at, that will be a, because a is constant and the differentiation of t is 1. So we will get ai cap minus differentiation of bt square is 2bt, because b is constant and the differentiation of t square is 2t. So we will get 2bt j cap. So this is the expression of the velocity vector we will get. Now for the acceleration vector, which is represented by w vector, is equal to derivative of the velocity vector with respect to time. So we can write d by dt of ai cap minus 2bt j cap. Differentiation of a is 0 minus differentiation of 2bt is 2b, because 2b is constant and the differentiation of t is 1, so we will get minus 2b j cap. So the acceleration vector we got, that is minus 2b j cap. So this is the acceleration vector and this is the velocity vector. Now we have to find the magnitude of the velocity vector. As I and j both are perpendicular to each other, so we can simply square a square plus minus 2bt whole square under root. So we will get a square plus 4b square t square under root from here. And if we write the magnitude of the acceleration vector, then we will get minus 2b j cap mod, that is equal to 2b. So this is the value of modulus of the velocity vector and the acceleration vector we got. Now in the C part, it is asking to find the time dependence of the angle alpha between the vectors w and v. So let us first represent the velocity vector and the acceleration vector. So velocity vector we have found out here, that is ai cap minus 2bt j cap, and acceleration vector we got as minus 2b into j cap. If we draw the velocity vector, then let us say this is x-axis, this is y-axis. So the component of velocity vector in the x direction is a, and the component of velocity vector in the minus y direction is 2bt. And so, and this is the resultant vector v vector. And if we represent the acceleration vector, then the magnitude of the acceleration vector is 2b in the negative of y direction. So let us represent it as this is the acceleration vector is equal to 2b. Okay. Now if we carefully look at here, the angle between the acceleration vector and the velocity vector is this one, and this is also the angle between the y component of the velocity and the resultant vector. So for that, what we can do, if we draw the vector diagram for the velocity, this is 2bt, this is a vector, and this is the resultant velocity vector v. So this particular angle is representing both the angle between the acceleration and the velocity, and the angle between the y component of velocity and the resultant velocity. So let us say this particular angle is alpha, so we can write tan alpha is equal to a divided by 2bt. So we will get alpha is equal to tan inverse of a divided by 2bt. So this is the value of angle between the velocity vector and the acceleration vector we got. Now let us come to the fourth part of the problem. In the fourth part, it is asking to find the mean velocity vector averaged over the first t seconds of the motion and the modulus of this vector. Okay. So if we write the velocity vector, that is equal to ai cap minus 2bt j cap, and the acceleration vector we are having minus 2b j cap. If we carefully look at the acceleration vector, so acceleration vector is a constant vector because its direction is in the always in the minus y direction, and the value of the acceleration is also constant. That means it is constant vector. And we know that if the acceleration is constant, in that case we can write the average velocity as v initial vector plus v final vector divided by 2. If the acceleration is variable, in that case we cannot write the average velocity like this. Then in that case, what we have to do, we have to write velocity into dt integral whole divided by dt integral. Okay, but in this case the acceleration is constant, so we can directly write the average between any 2 points of the velocity. Now if you find the initial velocity, that is equal to velocity vector at time is equal to 0, and this we will get it as ai cap, and final velocity is the velocity at time of t, that is equal to ai cap minus 2bt j cap. And if we substitute initial velocity and the final velocity in the expression of v average, then we will get v average is equal to ai cap plus ai cap minus 2bt j cap whole divided by 2, and then average velocity we will get it as ai cap minus bt j cap. And if we write the magnitude of this velocity vector, then we will get a square plus minus bt whole square under root. So this is equal to a square plus b square t square under root, and this is magnitude of the average velocity. So I hope the entire procedure is clear.